Calculating the electrical load for a fitness club involves several steps. Firstly, let's address the square footage calculation. The provided information lists 3,200 square feet, which may need adjustment if it is the total square footage of the entire fitness club versus just a portion requiring electrical power. The unit of measure for heating is typically British thermal units, or BTUs, or kilowatts. The information lists 30 kilowatts of heat. Similarly, for the water heater, the unit of measure is kilowatts, or gallons. The information lists a 10 kilowatt water heater. If the treadmill motors are reduced to 12 amps, the calculation can be adjusted accordingly. The show window requirements can be subtracted from the load calculation since a fitness club is not a store. The breaker size calculation is correct based on the adjusted load. However, it's important to consider the voltage of the electrical system. If the system is 208 volts instead of 240 volts, the breaker size needs adjustment. Similarly, the wire size calculation is correct based on the adjusted load, but the length of the wire run and potential voltage drop should be considered. Several additional considerations are also necessary. Firstly, the calculation does not include the lighting load, which can be significant. Secondly, if the fitness club has dedicated ventilation systems, such as exhaust fans or air conditioning units, their electrical requirements should be included. Finally, there may be other electrical equipment not listed, such as exercise machines, lockers, or showers. A qualified electrician should review the electrical design to ensure all aspects of the electrical system are properly accounted for. Let's delve deeper into each of these elements, beginning with a more detailed look at square footage calculations. The initial calculation of 3,200 square feet multiplied by 3, resulting in 9,600, might be excessive. The National Electrical Code, or NEC, provides guidelines for calculating general lighting and receptacle loads based on square footage. These guidelines differ depending on the occupancy type. For a fitness club, which is typically considered a commercial occupancy, the NEC specifies a certain volt-ampere per square foot requirement for general lighting and receptacles. This value is usually much less than simply multiplying the square footage by 3. To accurately determine the square footage load, refer to the appropriate NEC table, such as Table 220.12, which provides general lighting loads by occupancy. This table will give you the volt-ampere per square foot value to use for a fitness club. Multiply this value by the total square footage of the fitness club to obtain the total volt-ampere load for general lighting and receptacles. Next, let's examine the heating load. The provided value of 30 kilowatts represents the total heating requirement. To convert this to volt-amperes, which is necessary for load calculations, multiply the kilowatts by 1000 to get watts, and then divide by the system voltage. For example, if the system voltage is 240 volts, the heating load in volt-amperes would be calculated as follows: 30 kilowatts multiplied by 1000 equals 30,000 watts. 30,000 watts divided by 240 volts equals 125 amps. This represents the current drawn by the heating system at 240 volts. Moving on to the water heater, the 10 kilowatt rating indicates the power consumption of the water heater. Similar to the heating load, convert this to volt-amperes by multiplying the kilowatts by 1000 and then dividing by the system voltage. For example, if the system voltage is 240 volts, the water heater load in volt-amperes would be calculated as follows: 10 kilowatts multiplied by 1000 equals 10,000 watts. 10,000 watts divided by 240 volts equals 41.67 amps. This represents the current drawn by the water heater at 240 volts. Now let's consider the treadmills. Reducing the treadmill motor amperage from 16 amps to 12 amps significantly lowers the overall load. To calculate the total load for the treadmills, multiply the number of treadmills by the reduced amperage and the system voltage. For example, if there are 8 treadmills with 12 amp motors and the system voltage is 240 volts, the total treadmill load in volt-amperes would be calculated as follows: 8 treadmills multiplied by 12 amps equals 96 amps. 96 amps multiplied by 240 volts equals 23,040 volt amperes. This represents the total volt-ampere load for all 8 treadmills. Regarding the show window, since a fitness club does not require a show window, this load can be subtracted from the total calculation. Show window loads are typically calculated based on the length of the show window in feet and the specific volt-ampere per foot requirement outlined in the NEC. Since this is not applicable to a fitness club, this load can be omitted. The breaker size calculation involves determining the appropriate size of the circuit breaker to protect the electrical system. The calculation involves dividing the total volt-ampere load by the system voltage and a power factor, if applicable. The result is the total current. The next standard size breaker should be selected. For example, if the total volt-ampere load is 69,480 volt amperes and the system voltage is 240 volts, the total current would be calculated as follows: 69,480 volt amperes divided by 240 volts equals 289.5 amps. Based on this calculation, a 300 amp breaker would be appropriate. However, it's important to verify that the calculated load does not exceed 80% of the breaker's rating, as required by the NEC for continuous loads. This ensures that the breaker will not trip unnecessarily due to sustained high current. The wire size calculation involves determining the appropriate size of the conductors to carry the calculated current. The NEC provides tables, such as Table 310.16, that specify the ampacity or current carrying capacity of different wire sizes based on the conductor material, insulation type, and installation conditions. Select a wire size with an ampacity equal to or greater than the calculated current. For example, if the calculated current is 289.5 amps, refer to Table 310.16 to find a wire size with an ampacity of at least 289.5 amps. In this case, a 4/0 AWG copper conductor with a 75 degrees Celsius insulation rating would be suitable, as it has an ampacity of 290 amps. Remember to consider the termination temperature ratings of the equipment when selecting the conductor size, as the NEC requires the use of the lowest temperature rating for ampacity adjustment. In addition to the previously mentioned considerations, there are several other factors to consider when calculating the electrical load for a fitness club. Firstly, lighting is a significant load, and it's essential to accurately calculate the lighting requirements based on the square footage of the space and the type of lighting fixtures used. The NEC provides guidelines for calculating lighting loads based on volt-amperes per square foot. Secondly, ventilation systems, such as exhaust fans and air conditioning units, consume a significant amount of power. The electrical requirements for these systems should be included in the load calculation. Obtain the horsepower rating of the motors used in these systems and convert them to volt-amperes using the appropriate conversion factors. Thirdly, other electrical equipment, such as exercise machines, lockers, and showers, may contribute to the overall load. Obtain the power ratings of these devices and include them in the calculation. Exercise machines typically have a power rating in watts or kilowatts, while lockers and showers may have smaller electrical loads associated with lighting or ventilation. It is highly recommended to have a qualified electrician review the electrical design to ensure all aspects of the electrical system are properly accounted for. An electrician can perform a thorough load calculation, select the appropriate breaker sizes and wire sizes, and ensure that the electrical system complies with all applicable codes and regulations. An accurate electrical load calculation is essential for ensuring the safety and reliability of the electrical system in a fitness club. It prevents overloading of circuits, reduces the risk of electrical fires, and ensures that the electrical system can handle the demands of all the equipment and systems in a facility. A well-designed electrical system will provide a safe and comfortable environment for fitness club members and staff. In addition to the NEC requirements, local building codes and regulations may also have specific requirements for electrical installations. Ensure that the electrical design complies with all applicable codes and regulations. This may involve obtaining permits, submitting plans for review, and undergoing inspections by local authorities. Working with a qualified electrician who is familiar with local codes and regulations is essential for ensuring compliance. Regular maintenance and inspection of the electrical system are crucial for ensuring its continued safety and reliability. Schedule periodic inspections by a qualified electrician to identify and address any potential problems before they become serious. This includes checking for loose connections, damaged wiring, and worn-out components. Promptly address any electrical issues that are identified during inspections to prevent hazards and ensure the continued safe operation of the electrical system. Implementing energy-efficient measures can help reduce the electrical load and lower energy costs. Consider using energy-efficient lighting fixtures, such as LED lights, which consume significantly less power than traditional lighting fixtures. Install occupancy sensors to automatically turn off lights in areas that are not occupied. Use programmable thermostats to control heating and cooling systems and optimize energy consumption. Encourage fitness club members and staff to conserve energy by turning off equipment when it is not in use. By implementing these measures, you can reduce the electrical load, lower energy costs, and promote sustainability. Furthermore, emergency backup power is essential for maintaining critical functions during power outages. Consider installing a generator or uninterruptible power supply or UPS to provide backup power for essential equipment such as lighting, ventilation systems, and emergency communication systems. The size of the generator or UPS should be sufficient to handle the load of these essential systems. Regularly test the backup power system to ensure that it is functioning properly and ready to provide power when needed. Proper grounding and bonding are essential for electrical safety. Ensure that the electrical system is properly grounded and bonded to provide a low impedance path for fault currents. This helps to prevent electrical shock hazards and reduce the risk of electrical fires. Follow the NEC requirements for grounding and bonding to ensure that the electrical system is properly protected. Overcurrent protection is another crucial aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. Ensure that the circuit breakers and fuses are properly sized for the circuits they protect. Regularly inspect the circuit breakers and fuses to ensure that they are in good working condition. Replace any damaged or worn out overcurrent protection devices immediately. Surge protection is also important for protecting electronic equipment from voltage surges. Voltage surges can damage sensitive electronic equipment such as computers, exercise machines, and audiovisual systems. Install surge protection devices at the main electrical panel and at individual equipment locations to protect against voltage surges. In conclusion, calculating the electrical load for a fitness club requires careful consideration of several factors, including square footage, heating, water heaters, treadmills, lighting, ventilation, and other equipment. Following the NEC guidelines, local building codes, and regulations, and working with a qualified electrician are essential for ensuring the safety and reliability of the electrical system. Regular maintenance, energy-efficient measures, emergency backup power, proper grounding and bonding, overcurrent protection, and surge protection are also crucial for maintaining a safe and efficient electrical system in a fitness club.